This is Josh, and he's going to be demoing his projects related to custom musical instruments. So go ahead and take it away.
Or just make sure I'm doing this right. Alright, yeah. Hello, my name's Josh, and I am doing SPI. I was doing SPI this year, and my SPI project was custom making musical instruments. Is there a laser? There is a laser, but it doesn't work on the screen. Yeah. Yeah, analog music, or learning to take apart things and make something new. So basically, first of all, there's a little disclaimer. I could not get everything that I wanted to do this year done. I was able to get one thing done that I thought was pretty cool. But there was a lot that was still to be learned in the process of being able to do these things and being able to make, or at least research how to make these kinds of instruments. So, how are audio signals generated? If you can imagine, like any electronic instrument, it's really just a fluctuation of voltage, and really any fluctuation of energy can be translated into some kind of audio voltage. And just, for example, over there, I'll show you later. But basically, for example, a square wave can be made just by having a fluctuating constant voltage that goes up and down from 0 to 1. So basically, what I was trying to do is trying to find ways to emulate this kind of effect and be able to turn this into a practical musical instrument. So this was something that I created over last summer. I did not know that another project called Ops is doing something almost exactly the same. But it basically did the thing where you go from 0 to 1 in terms of voltage, and you're able to create some kind of waves. And it was an Arduino, and if you can't really see it, there are photoresistors here and LEDs over here that light up if I plug it in. And this is completely digital because it uses Arduino. However, I did also find a waveform generator in Japan that I was able to construct, because they sell it in little packets, little kits. So if you can see over here, I actually made that from the PCB kit that I bought, and it basically creates square, triangle, and sausage waves, which are just different shapes of waves. And there's a pitch and volume control on it. That green, no, that blue thing on the left side is the volume, and that giant knob is the pitch control. And if you can see, there's a little black box somewhere right diagonal down from those two screws over there. That thing's a transistor, and that thing does a lot of the waveform generating. But I was not necessarily able to test this thing out per se. And this thing was supposed to be my main inspiration for what I was doing, including the barcode scanner, which is basically a musical elective from Japan that actually turns these kinds of things into musical instruments. And if you can see, the one over here uses an electric fan, the one over here uses a barcode scanner. And what I was able to do is create a barcode scanner synthesizer. This is the one thing that worked for my project. And what happened was I ordered this off Amazon, and there's this little thing here that has a bunch of little probes coming out, like these soldering leads. And I just probed in using these cables, and I was able to plug it into an oscilloscope. And what happens is, the way a barcode scanner works is that it reads a high and low signal. And depending on the high and low signal, it's going to have an output. And in this case, the spaces in between will dictate that. And if you can see, there are these little bumps here. Not the very obvious ones. The very obvious ones, I'll get into what that is, but you'll be able to see that it actually has a signal that comes out. The bumps that are generated are because it has a timing protocol in it, and it actually created noise that I did not necessarily want, but it's still very interesting to see how it works because of the whole timing protocol behind this kind of barcode scanner. And then the electric fan, I was trying to work on it. This was supposed to be how it worked. This thing is supposed to spin, and every single one of these lines corresponds to a different frequency that goes from the center outwards, the outside being higher in pitch and the center being lower in pitch, because the frequency is lower for the ones in the center. As you can see, the lines are much longer. And this thing here is supposed to be the thing that senses the spaces in between. There's a phototransistor, which is the thing below it, and an LED on top. And basically, every time there is a fluctuation, every time there is a light that is allowed through, we have a high signal. Every time there's a sound that's not, like a light that's not going through, we have a low signal. And that's the operating principle. However, I was not able to get it done in time, but it's very interesting the way that they actually did it was that the band was able to use I think it was an electric doorknob, and they're able to use that phototransistor and translate it into the synthesizer that they were working on. And the prospect behind it is that you'll be able to use creativity to turn mundane objects, barcode scanners, electric fans, or anything like that, into musical instruments and create sound Also, just having a better understanding of the connection between the world that we observe and how we can turn that into what we want using electrical engineering, as well as being able to exploit technology in however we like, in however ways that we desire to be able to make what we want from it. And to end it off very quickly, I'm going to try demonstrating it right now. So if there's nothing crazy going on in my desktop, yeah. So this is my amplifier. This is the barcode scanner synthesizer. There's a cable plugs in like this, and yeah, there's a red light, and then I will need to borrow you. Yeah. Yeah. I'm gonna borrow. My buddy over here has an instrument cable, and you see what I did was that I was able to get a audio jack, and I was able to solder on some of these leads into the inside where there's supposed to be a signal coming out. And what I'll do is I'll plug it in my notebook, literally just now, I wrote these lines here to be able to basically treat it as this sound. And so the sound you're hearing right now is the timing protocol that's used to determine like when to stop and when to start. And if I hit it, let me make it louder. Yeah. So that's how it works. You can hear that there's a difference in the speed of the clicking as well as the frequency that's being sent through. Sometimes it kind of acts like a low pass filter or a high pass filter depending on how far away it is. Because the frequency that's I'm detecting is different depending on distance and depending on the space of the lines. So that's basically all that I have. Here's the funny thing that they have to say. Thank you very much.